So now that we have a good idea about how to determine the types of hydrogens in rings and in simple structures, we want to go a little bit deeper and we want to look at what we call the chemical equivalency test. So if you're ever unsure if two protons are equivalent to each other, you can do the chemical equivalence test or the X test. In this test, you would draw the compound twice. In one of the drawings, you'd replace one hydrogen with an X. In the second drawing, you'd replace the other hydrogen with an X. If the two new structures you drew that contain the X are identical to each other, then the protons have to be identical. If the two structures are enantiomers, then the protons are enantiotopic, but they are still equivalent. So they would give one signal in the NMR spectra. If the two protons result in diastereomers, then the protons would be considered diastereotopic and therefore not equivalent. When this happens, you would get two different signals in the NMR spectra. When we're trying to decide if something is enantiomeric or diastereotopic. For something to be an enantiomer, it would result in having, for hydrogens to be enantiotopic, it would result in two different diastereomers. We can end up with the S isomer and the R isomer. If you end up with two enantiomers like this, you will get just one signal in the NMR spectra for both of those hydrogens. If when you replace one of the hydrogens, you end up with a diastereomer, then you would get two signals. You would get one signal for your first hydrogen, and you get a second signal for the second hydrogen. So it's one thing to watch out for with diastereomers. You end up with more peaks in the hydrogen spectra than you would expect. If you notice that your compound of interest already has a stereocenter, you'd want to watch out for diastereotopic hydrogens, and if it gives rise to diastereomers or not.